to convert a matching a letter to a number. Of course you can change it, but it's going to be the same, so unless we say something else, we are going to follow this method. Okay, the first affine cipher style is going to be additive cipher or shift cipher, and the famous seizure cipher is one of these cases. And as the title says, the way we cipher the plain text in this manner is just simply pushing the position of this letter by a certain number. Of course, there are only 26 letters in the alphabet in English, so we can just move up to that much, and it's by modulo 26, which means if you get more than 26, actually just return to 0 and count, continue the count. And we call the number of units that shifting for the shifting is the key. So the first one is additive cipher, and with key K means from the plain text, let's say just choose one letter from plain text and convert the letter to the assigned number and adding the key, which is a number. So it could be 3, 13, 24, whatever it is, and our cipher number is going to be modulo to this sum. And of course it's by modulo 26, so if that number after adding this number is greater than 26 or equal to 26, then we have to take the residue for the remainder of the number after dividing by 26. And to decrypt that ciphertext into plain text, just exactly the opposite way. So convert the letter from the ciphertext to a number and subtract the key, and that will be our plain text number, actually number for the plain text, right? And take the modulo 26. Okay, so when k equals 3, that is the famous seizure cipher, and it is kind of used by seizures. Okay, and this is the one. Okay, so let's see an example for that. Let's say our plain text is I'm a student, and at this moment we don't assign any number for the space, so we cannot handle a space. So let's just put as a kind of one word like this, and our key is 5 in this case. Then for the encryption, for each letter needs to be changed to a assigned number, and we have to add the key, which is 5. Then there must be a assigned letter for that results, right? And in this case it's going to be n, so I needs to change n, a needs to change f, and just keep doing that way. So this result, that should be our ciphertext. So if it's not 5, 7, 9, 11, whatever, then it just got that new kind of word for the ciphertext. Okay, to encrypt that ciphertext, and if you know the key, then simply just subtract 5 from the assigned number to each letters in the ciphertext and change that result to assigned letter, then we got the plain text again. So it changed back to I am student. Okay, I'm a student. Now the possible question at this moment is there are only 26 letters in alphabet English, right? So the way we can shift is up to 26. So one of them is identical one, right? So it's not really cryptology, but anyway, so we have total 26 possibilities, and if you really want to change it, then there are 25 possible keys. Okay, but to break the ciphertext without knowing the key, in this case, actually it's simple enough. all we need is just apply all the possible keys to the ciphertext. So for given this ciphertext, if we just assuming key is 1, then subtract 1 to the number assigned to these letters and change it back to letters, and this is the kind of possible plain text. Doesn't mean anything, so we know 1 is not the key. So we just do the same thing like that. So when key is 5, we got the reasonable result, right? In the worst case is maybe if our plain text is not long enough, then we might got kind of another reasonable results over there, but it's kind of rare case. Right now we are not going to pay attention for that case. So with this method we can just got the plain text. So that's the reason why this kind of monoalphabetic is not secure enough, because anyone could guessing the results, right? The plain text by that. Okay, so if you do up to 25 for the key, these are all the results we got it.